Hello everyone. So this video we're going to be solving some trig equations from section 7.4. So we'll start off with something very basic and then we'll work into some more advanced equations. So let's review on the two type of angles. You have first a degree. The second type of angle is radian, and their name for radian would be a real number. So why is that? Well, radian comes from the measurement of the arc length around the unit circle. And so that's really a measurement of a length. And so you can view it as a real number, distance really. And degree is a rotational measurement. Okay. All right, and here it is, our very first example. The equation is sine of x is equal to 1/2. It's a very basic equation, and the condition for solving this equation is that we want to solve for all solutions in degree. Okay, that means that I want to solve for all x values such that when I plug into this equation, sine of that x value will equal to 1/2. So 1/2 is actually a pretty nice value. We actually do know the position on the unit circle that would give us the y value being 1/2. So we want sine to be 1/2. That's exactly saying we want the y coordinate on the unit circle to be 1/2. And so there's two positions for that. The first position is in the first quadrant with angle 30. And by the symmetry of this unit circle, there is a second position in the second quadrant that would also give us the y value 1/2. Now the reference angle is 30. But to call out this position, you would use the angle from the initial side to the terminal side. And because this is 30 degrees less than 180, to get this position, I would need to use 150. So right away, I already have two solutions. The first guy is 30, and the second solution would be 150. Now, is that it? Well, in terms of position, that's it. You only have two unique positions, but there's a lot of ways to get to these two positions. So for example, instead of going 30, I could have gone the other direction, the clockwise direction, and get to the same position, but it would be a negative angle, and it would be a negative 330. Okay, what's another way to get to this position? So let's think about the clockwise direction. That's 180, and then you need to go 30 degrees more. So that's 180 and an additional 30. So that's going to be 210. Okay, but we went the negative direction, so that's a negative 210. Okay. All right. And we can actually get more by adding or subtracting 360. Because for any coterminal angle, you just add or subtract 360, you get another value for the same position. So I can keep on going. Let's add 360 to this guy. I'll get 390. That's another value for this position. If I add 360, I'll get 510. And really this list will be an infinite list. So if you have to list out all solutions, it is impossible because there's no way for us to list out everything. But there's a very clever way of just stating all the solution. So here we'll start with the first solution, but for any coterminal angle to this 30 degree, you can add or subtract any multiple of 360. So we'll say 30 plus 360 times k. And that's another way of saying for any multiple of 360 being added on to 30, that's another solution. we'll do the same thing for this 150. 150 is a solution, but I can add or subtract 360 to this 150, any multiple of 360, and that'll give me a coterminal angle to this position here at 150. And together, this would give us all the solution to this very simple trig equation. Okay. All right, let's do another example. This time I'm going to do a cosine, and this time let's try -1. So cosine of x is -1. This is my equation, but for my condition, I want to solve for all real values x. And that's just another way of saying find all the solution to this trig equation, but I want x to be a radiant value, not degree. So here, real values is just another way of saying you want the solution to be radiant. So -1 is a nice value. I'm going to look on the unit circle. I'm looking for cosine values being -1. Cosine gives me back the x coordinate on this unit circle. So on this unit circle, if you want x to be negative, the only way to do that is this position. So there is only one position on this unit circle that would give me my x value to be -1. How do I get to this position? What angle is that? Well, if you say 180, you're not wrong, but for this condition, you're actually wrong, because we do not want 180. We want the radiant value for the solution, and so we want to use the value pi. Okay, so pi would give me this position, and that will give me cosine of pi being -1. All right. Is that the only value that would give me this position? No. For any coterminal angle to pi, that would also be a solution. So you can think of another solution as -pi. So that's another solution. What's another solution? I could go 2 pi and then another pi. So that's 3 pi. How about 2 pi, 4 pi, and then I'll do another pi. So that's 5 pi. And I can keep on going. The list will be an infinite list. And we can't really list out all the solutions. So there's a clever way of just being able to state all the solution without having to list all of them out. So we're going to use the first angle, and to generate all the other coterminal angle to pi, you just add any multiple of 2 pi. This is different from the first example because to go around a circle, a full circle in degree, that's 360 degree. But in radiant, to go around the circle, that's 2 pi. So adding or subtracting a multiple of 2 pi will give you another coterminal angle to this angle pi. And that is it. There is only one unique solution, so that's it. And you would say x is equal to pi plus 2 pi k for any integer value k. Okay. All right, let me do one more example. I'm going to do another video where I'll get into a more of a advanced equation, but for this video, I'll keep it simple. So let's say I want to solve for 3x, sine of 3x is equal to negative root 3 over 2. And I want to solve for all real values. Okay, and that's just another way of saying I want my solution to be in radian. Okay, so this is still a very simple trig equation. Sine of something is equal to negative root 3 over 2. And negative root 3 over 2 is a very nice value. We know exactly the position that will give me this value as my y value. Sine is going to give me back the y value on this unit circle. So we're going to be looking for any position on this unit circle with the y value being negative root 3 over 2. If y is a negative, that means that it should be below the x-axis. Any y value above the x-axis will be positive, but we're looking for the y value being negative, so it's going to be somewhere down here. There's probably a position over here with the y value being negative root 3 over 2. And there is another y value, another position over here where the y value is also negative root 3 over 2. And this comes from a very nice right triangle. If I know that's a 1 and I know this must be root 3 over 2, then I know this is a 1/2. Okay. All right, so in this right triangle, I know the angle next to the 1/2 and 1 is a 60. So this reference angle is also a 60. So I can actually figure out what angle I should use to evaluate sine with to get this y value negative root 3 over 2. But here's where we're going to be very careful, because sine takes in the angle and x turns out to not be the angle. X is not the input. The input for sine is not simply x, it's 3x. So when I'm solving for the angle, I'm not solving for x, I'm actually solving for 3x. Here, the equation is asking for a sine of 3x is equal to negative root 3 over 2. And so the input for sine would be 3x. So what angle should I plug into sine to get negative root 3 over 2? Well, the first angle, to get this position, you can use the counterclockwise value or the clockwise value. I'm going to go with the clockwise value, and that's a negative 60. Okay. Well, that wouldn't be correct because I'm looking for real values, which means I'm looking for radiant value as my solution. So what's negative 60 in radiant? That's negative pi third. How do I get this other position? That's pi with another pi third. So that's going to be pi over 4. Okay, and this would not be x. This would actually be 3x. Because that's the input for sine, and so that's the angle. The angle is 3x, so negative pi over 3 is the 3x, pi over 4 is equal to 4 pi over 3, sorry, is the 3x. And there's infinitely many more. We cannot list them all out. So there's a clever way to do that. the angle, which is 3x, is equal to any coterminal angle to these two angles. So negative pi over 3 plus any multiple of 2 pi would be a solution. And it would be a valid angle. So any of these can be equal to 3x. You can take 4 pi over 3 plus any multiple of 2 pi, and that'll be another angle that you can plug into sine to get this negative root 3 over 2. But we're not solving for the angle, we're solving for x. So here, the angle, which is 3x, is equal to any of these values. In order to get x, you have to divide out this 3. So if you divide out the 3, that means everything on the right side will also have to be divided by 3. So really, this is a shortcut of writing two equations. The first equation is this guy. The second equation is this. And you have to solve for both equations, and that will give you the solution for x. For the first equation, you divide the left side by 3. You have to divide the right side by 3. So the whole thing divided by 3. So the negative pi over 3 divided by 3 is negative pi over 9. And the 2 pi k divided by 3 is the 2 pi k divided by 3. I'll put the 2 pi over 3. Same thing for the second equation. The left side is divided by 3. The right side is divided by 3. So that's going to give me just x for the left side, and for the right side, it's this first guy divided by 3 and the second guy divided by 3. And that's going to give me a 4 pi over 9 plus 2 pi over 3. Okay. So I'm going to combine that into a single statement. So my first set of solutions will be negative pi over 9 plus any multiple of 2 pi over 3. And my second set will be 4 pi over 9 plus any multiple of 2 pi over 3. And where k can be any integer. So this here would be the solution set for all x values. But x is not the angle. So to solve this equation, it is a two-step process. The first step is to solve for the angle. So 3x is the angle. We have to figure out for what angle do I plug into sine to get negative root 3 over 2. Here I found the two locations that would give me negative root 3 over 2 as my y value. And these two locations would be the negative pi over 3 and 4 pi over 3. And so the 3x, which is the angle, can be negative pi over 3 or 4 pi over 3. But we know that we can add on any multiple of 2 pi, and that will give me the same position. And so I can generate all angles by adding 2 pi k to the negative pi over 3, add any multiple of 2 pi to 4 pi over 3. And so this would generate all the angles that I can plug into the sine to get this negative root 3 over 2. But I'm not looking for the angle, I'm looking for the x value. So once I have all the angles, which is 3x, I divide all the angles by 3, and that will give me the solution set for x. Okay, so this is the first step, first half. And once I solve for all the angles, which is my 3x, I complete my second half by dividing out to 3, and that'll give me the set of all x values that will satisfy this trig equation. Okay, so for this video, I'm just going to stop here. And for the next video, I'll introduce more complicated trig equation, and we'll try to figure out how to solve for those. Okay, so I'll see you guys in the next video.